Hey guys, Miss Dyer here. Hope you had a good Thanksgiving break and you're ready to get started. Give it one last push to get through this semester. We have about 3 more weeks left, and we're going to be starting on our last unit today. So last unit in chemistry, yay! Um, this unit, we're going to be doing stoichiometry, and we'll talk more about what that is a little bit later, because before we do that, we've got to learn how to do what we call the factor label method. So I'm going to be showing you today how to make metric conversions using the factor label method, just to kind of help you learn how to do the factor label method. The point here is not as much about learning the metric system as it is about how to do the switching from one unit to another using the factor label method. So what I'm going to be showing you today, the way I'm going to be showing you to do it, that is what we're going to be doing for the rest of the semester. Pretty much, we're going to be using the factor label method to do different conversions, to change one unit to another. We're going to start out with metric conversions tomorrow. We're going to do English metric conversions, and then by the end of the week, we're going to be doing chemistry conversion. So what we're doing here, the first two or 3 days of this unit, is going to be more math than it is really chemistry, because I'm trying to teach you how to do this factor label method. Once you've kind of learned how to do the factor label method, then we're going to start doing chemistry using the factor label method. So when I show you how to do this, I don't want you to say, oh, well, I know an easier way to do that. No, okay? Because when we get to doing some of these problems in chemistry, they're going to be really, really long. And if you don't know how to use the factor label method, you're not going to be able to get an answer. You're not going to be able to get a correct answer, because the factor label method is going to take us from the beginning to the end of a really long problem that's not going to be so easy. So what we're doing today, tomorrow, even the next day, for the next few days, you're going to think, oh, well, I know how to do that. I don't have to do all this stuff that she's doing. Yes, you do. Okay, you need to do it exactly the way that I show you to do it. Because if you don't, then when we get to the really long, hard problems that are harder, they're not as easy to do, then you're not going to have a clue how to do them. Because these here at the beginning are going to seem a little bit simple, and like, why do I have to go through all that mess to do this problem? Because you guys, really, it's just going to be a matter of adding and subtracting. Or I'm sorry, not adding and subtracting, but multiplying and dividing. Mostly what we're going to be doing when we use the factor label method, it's going to be all multiplying and dividing. And you may be a person who can look at it and say, oh, wait a minute, I just need to multiply those two numbers. Or, oh, I just need to divide those two numbers. Okay, it's going to be that simple here at the beginning. But as I said, when we get into these chemistry problems and the really, really long, hard chemistry problems, it's not going to be simply a matter of, oh, I just need to multiply or I just need to divide. It's going to involve multiplying more than once and dividing more than once. And so if you know how to do the factor label method, you can still get the answer to that problem. If you don't, then you're going to be lost. So what you need to focus on here is not just getting an answer and, oh, I can multiply or divide that to get an answer, but is how do I get the answer using the factor label method. Just as I did in the last unit with writing formulas and naming compounds, you are going to be doing your work on a piece of paper, taking pictures of your work and uploading it to these slides. I have to see your work. I have to see that you are working these out using the factor label method, because eventually that will be the only way you'll be able to get a correct answer. So if we're going to start out using the factor label method to do metric conversions, then we're going to use something called the Z-chart. Now, the Z-chart can actually be used in a different way than what I'm showing you here. What I'm showing you here is not how to use the Z-chart. I'm just using the Z-chart to give you some of these what we call conversion factors. So whenever we use the factor label method, we have to have conversion factors that show us the relationship between the different units that are in our problem. And so we're going to use the Z-chart not for its intended purpose, which we're not going to go into that because that's not how we want to use it. We want to use it to do the factor label method. So we're going to use the Z-chart to get our what we call our conversion factors. So, and again, you will notice here I have boxes here that you can click on and type in, and that's what I'm going to be doing, and that's what you're going to be doing. So first thing, I want to call your attention to this blue box. You guys, that blue box represents one of any unit. So the units that we're going to be using today are grams, meters, and liters. We're just going to be using some different metric units. So that blue box represents 1 gram, or 1 meter, or 1 liter. Okay, so that's what that blue box represents. So anything above that blue box is bigger than 1. So that's what we're going to put here. Anything above the blue box, so all these up here, are bigger than 1. Anything below the blue box is smaller than 1. And I didn't make that as big as I wanted to. Anyway, so you're going to see that when we're using below the blue box, these are all smaller units, with this P being the smallest. P is for pico. N is for nano. This little weird looking U is for micro. This M is for milli. This is centa. This is deci. This is deca, hecto, kilo, and mega. So what we're going to do is we're going to talk about how many grams or meters or liters are in one of these, and then there's going to be a bunch of these in 1 gram, meter, or liter. So we're going to start down here really small and go up to really big. I'm actually going to start backwards. So I'm going to start up here at the top, and we're going to say that 1 meter is equal to, and you guys, pretty much what we do is we go up by factors of 10. So this is 10, 100, 1,000, 10,000, 100,000, a million. So basically this M is 1 million. So 1 meter, or what I should say is there are 1 million meters in 1 megameter, for example. Okay, and again, that doesn't have to be meter. That could be 1 million liters in a megaliter, 1 million grams in a megagram. Okay, so it doesn't have to be meter. I'm using meter here, but it could be gram or liter as well. Okay, and so if we were going to put that in terms of, because I mean, you guys know that's pretty big. If we were going to put that in terms of exponents, a million is 10 to the 6th, 10 to the 6th power. So, because sometimes you'll see it written as that, so I just want to go ahead and use that. So there are 10 to the 6 meters in 1 megameter. And I'm actually going to probably put that 10 to the 6 on the other side. That way you can see there. And again, you don't have to use the 10 to the 6 and the million. I'm just going to use the million, but again, a million is 10 to the 6, so that's why I put it there. Okay, so moving on, kilo, like a kilogram, a kilometer or kilometer, or a kiloliter. Kilo means 1,000. So that what this means is that there are 1,000 meters in 1 kilometer or 1 kilometer. And again, 1,000 is 10 to the 3rd power. Again, just giving that to you in terms of exponents there in case you would rather use those. So 1 million meters in 1 megameter, 1,000 meters in 1 kilometer. Again, you can see that there's a couple of steps between these two. So again, basically 1, 2, 3, this is 3 times smaller. So 1,000 is 3 times smaller than a million. So, all of these are just steps of 10. So coming on down, notice this is just one step. So hecto, H is hecto. Hecto is 100. So basically there are 100 meters in 1 hectometer. And again, 100 is 10 to the 2. So if we wanted to put that in terms of exponents, 100 is 10 to the 2. And I just have to make that 2 an exponent. Okay, moving on. Again, one step. So this is 10 times less. So there are 10. There are 10 meters in 1 decameter. I know that looks weird. DAM, D-A-M. But that's how you abbreviate decameter, D-A-M. So there are 10 meters, which is, again, 10 to the 1. Now, I'm not going to put that in an exponent because you guys, you don't need that. 10 is pretty easy. Okay, so all of these are bigger than 1. So that means we have more than 1 meter in one of these. It takes several meters to make one of these. Okay, remember that these are smaller than 1. So it's going to take several of these to be 1 meter, or again, it could be 1 gram or 1 liter. So you can substitute all the M's here, these small M's, you could substitute the G's or the L's. It can be any of them. Okay, so coming down below 1 gram, 1 meter, or 1 liter, we're going to look at deci. Deci is 1/10, guys. So basically, this is 1/10 of a meter. So, one decimeter is equal to 0.1 meters. Okay, and again, the other way you could write that, you could say, oh, there's 10 decimeters in 1 meter. 10 decimeters in 1 meter. But what we're going to do, we're just going to say, okay, 1 decimeter is 1/10 of a meter. Okay, again, these are smaller than 1. So 1/10 of a meter. Okay, centa is 100. Or it's 1/100th. It takes 100 centimeters to be 1 meter. And I'm not sure which way you guys would rather me do it. I might just go ahead, instead of using the decimals, and say, okay, 10 decimeters in 1 meter. I think that might be easier. Okay, so 10 decimeters in 1 meter. So several of these in 1 meter. So centa is 1/100th, which means it takes 100 centimeters to be 1 meter. Okay? Milli is 1,000, which means it takes 1,000 millimeters to be 1 meter. Micro is 1/1,000,000th. So that means it takes 1 million. Again, notice how these are getting very small. 1 million micrometers to be equal to 1 meter. 1 million is very small. Moving on, nano is 1/1,000,000th. So that means it takes 1 billion. Again, this is really tiny. It takes 1 billion of these to be 1 meter. So again, if we were to take a meter stick and to slice it into 1 million equal pieces, one of those 1 million pieces would be a nanometer. And then lastly, pico is the smallest one. Pico is 10 to the minus 12. So basically it's 1/1 trillionth. And so it would take 1 trillion picometers to be 1 meter. So if we were to take a meter stick and put it in and divide it into 1 trillion equal pieces, one of those 1 trillion pieces of that meter stick would be 1 picometer. So you can imagine how small that would be. It is so, so small. So anyway, these are what we're going to call our conversion factors, okay? So these are the conversion factors that we're going to be using as we do the factor label method. And so what we're going to do now is we're going to use these conversion factors to switch from one unit to another using the factor label method. Now, what you're going to be doing, as I said, you're going to be doing these on paper, showing your work, taking a picture, and submitting your work on here. So I've left this whole side of the slide blank. So you can do all 5 of these on one thing, take one picture of it, and then insert that picture onto this slide, and do them in order because that will make it easier for me to look at it, make sure you're doing it correctly. So these next 3 slides are ones that you're going to be doing for your own practice. So I'm going to be doing some different examples. Okay, so here's a problem. Notice how my problems are just exactly like yours. The only difference is my problems are in yellow and yours are in white. Okay, but the same format. So what we're going to do, and these are the steps that you're going to take to do the factor label method. The first thing we're going to do is we're going to take what we are given and put it over 1. Okay, so the factor label method, we have to use conversion factors, which that's what these things are here on our Z-chart. These things are our conversion factors. Now, all conversion factors won't be on a Z-chart, but the ones that we're using today are. So these are our conversion factors. And then what we're going to do is we're going to use ratios or fractions. I'd rather call it a ratio because a fraction kind of sounds scary, because I know you may have had nightmares about doing fractions in grade school. So we're not going to call it fractions. We're going to call it ratios. So we're just going to turn everything into ratios. And then we're just going to be multiplying and dividing and getting an answer. Okay, so the first thing we're going to do is we're going to take what we're given in our problem. So this is our first problem. And we're going to put what we're given over 1. We're going to turn it into a ratio. So 952 grams. Well, 952 grams over 1. That's always going to be your first step. Okay? Now, we're going to do another ratio to let us change from gram to DAG, which is decagram. So guys, what we want to do before we put any numbers in, so we've got our first ratio here, taking what we're given and putting it over 1. What we want to do next is when we do the factor label method, what we want to do is to cancel out our units. That's what we want to do, cancel out our units. So I can put grams. All I care about right now are the units. I don't care about any numbers right now. All I care about are units. So I can put gram either here on the bottom or here on the top. Okay, again, I need to cancel out grams. So if it's in the top here, I'm going to need to put it on the bottom over here to cancel out. If it were in the bottom, I would put it in the top. But because it's on the top, I have to put it on the bottom. And this is the way you're always going to do it. Take what you're given, put it over 1. Whatever unit we have on the top here, that unit has to go on the bottom here so it will cancel out. So the unit that we were given goes on the bottom in our second ratio so that it will cancel out. And then the unit that we're solving for goes on the top in this second ratio. So decagram is what's going to go on the top here. And now I have to check and see, do I have a ratio that will let me go from gram to decagram? Do I have a conversion factor that has both of these in it? So let's look at our Z-chart. Do we have a conversion factor that has G and DAG in it? Remember that all of these M's, you can substitute G or M or L. So do I have one of these that would have DA and G in it? Okay, DAG and G. I hope you said it would be this one. Notice that this M, okay, that could be a G. And this DAM could be DAG. Okay, remember I said the M's. It doesn't have to be M's. It can be G's or L's. It can be any of these 3. So do I have a conversion factor that has G and DAG in it? Yes, I do. Okay, so in my conversion factor, there is a 10 in front of G. So that's what I'm going to put in front of G in my problem. 10. Again, these numbers, notice I did my units first. I set it up so that my unit would cancel out. And the unit that I'm solving for is the unit that is left. Once I get my units set up so that the one that I'm given is canceling out and the one that I'm solving for is the one I will have left, then I'm ready for my numbers. So I look at my conversion factor and I find a conversion factor that has both of those units in it, the G and the DAG, and this one would be it. So now I'm going to get my numbers. The number in front of G is 10, so that's what I put in front of G in my problem. The number in front of DAG is 1, so that's what I put in front of DAG in my problem. Okay, so now I have it set up so that my units will cancel, so I'm marking them out. Now that I have my problem set up, my grams are gone, and I'm changing to decagrams. Now I am ready to multiply and divide. So what you're going to do is you're going to multiply across the top, multiply across the bottom, and then divide the top by the bottom. So let's multiply across the top. 952 times 1 is 952. And again, that is DAG. Okay, on the bottom, I have 1 times 10. Again, gram is gone. Gram canceled out because I have 1 on top, 1 on bottom. They cancel out. So 1 times 10 is all I have on the bottom. 1 times 10 is 10. Now we're going to divide 952 divided by 10. If you don't know what that is, just look up scientific calculator on Google. There you go, 952. And it doesn't have to be a scientific calculator for this right now, but later on it would probably be useful. Divided by 10. And my answer is 95.2. And I'm sure you guys could do that in your head, but I'm just showing you how to do it if you weren't able to do it in your head. So 900, oh, I messed up. It's 95.2, not 9.52. It's 95.2. 95.2. And don't forget your unit, decagram. I don't want to see an answer without a unit, guys. Our answers have to have units, so make sure that you give me a unit. All right, let's do another example. Again, my problem, 5.287 liters, that's an L, equals how many milliliters, okay? So first thing we're going to do is take what we're given and put it over 1. 5.287 liters over 1. And I might even go ahead and make that a big L, so that way I can tell the difference between my 1s and my L's. Okay? Now, I'm going to set up my next fraction, my next ratio. I don't care about numbers right now. All I care about are my units. I want to cancel out this unit. So where do I put it so it'll cancel out? It goes on the bottom. Okay? Now, what do I want to change it to? This is what I want to change it to, so that's what goes on the top. Okay, so now I've got it set up so that my units will cancel. If you want to go ahead and cancel them out, you can. Okay, but I need a conversion factor that has an L and an ML in it. So let's go see. I'm going to go ahead and make that a big L as well. Let's go see if we can find one that has an L and an ML. Okay, well, remember we can change the M's to L's as well. So ML, you guys, that's milliliter. Where is milliliter? Okay, milliliter is right here. So let's just make that an ML. And then this M becomes an L. Okay, so 1,000 milliliters in 1 liter. So now I have a conversion factor that has milliliter and liter in it. So 1,000 in front of milliliter in my conversion factor, 1,000 in front of milliliter in my problem. 1 in front of liter in my conversion factor, 1 in front of liter in my problem. Okay, so now my liters are canceled out. Milliliter is what I'm solving for, and that's what I have. Now I'm ready to multiply across the top, multiply across the bottom, and then divide. So when I multiply across the top, 5.287 times 1,000 gives me 5287. And if you don't know if that's what that is, then you just type it in over here. 5.287 times 1,000. And it is 5287, 5,287. And then don't forget you still have milliliter there. Okay, on the bottom we have 1 times 1, which is 1. Now we divide. 5,287 divided by 1 gives us 5,287 milliliters. And again, don't forget to give me units within your answers. Okay, let's look at one more. Again, my problem, 8.412 meters equals how many centimeters? Okay, the first thing we're going to do is take what we're given and put it over 1. 8.412 meters over 1. Next thing we want to do, set up our next ratio so that meters will cancel. Where do we put it so that meters will cancel? On the bottom. Okay, so now, what do we want to change to? That's what goes on the top. Well, we want to change to centimeters, so centimeters goes on the top. Okay, now we have it set up so our meters will cancel. We can go ahead and mark it out if we want to. But I need to find a conversion factor that has both centimeters and meters in it. Again, this is centimeter. So where do I have both centimeters and meters? Okay, right here, cm and m. In our conversion factor, there is 100 in front of the cm. So that is what I put in my problem, 100 in front of the cm. In my conversion factor, there is a 1 in front of the m. So that's what I put in my problem, a 1 in front of the m. My meters are canceled out. I have the centimeter, which is what I'm solving for. So now we multiply across the top and across the bottom. 8.412 times 100. If you don't know what that is, multiply it on a calculator. 8.412 times 100. You guys, you can use calculators in chemistry. I don't know about math, if they're letting you use them or not in there, but you can use them in chemistry. So it's 841.2. And then centimeters. On the bottom, we have 1 times 1. So 841.2 divided by 1 is equal to 841.2 centimeters is our final answer. Okay, let's do one more. Let's say that we have 1,211 meters, and we want to know how many hectometers that would be. Okay, so again, this is what we don't know. This is what we do know. So what we do know, what we're given, let's put it over 1. 1,211 meters over 1. Okay? Then set up our problem so that meters will cancel. What we're given, we want to cancel. Again, we're just looking at units. We're not looking at numbers yet. So put meter on the bottom. What do I want to change it to? Well, I want to change it to hectometer. So hectometer goes on the top. So now we need to find, now we're worried about numbers. Once we get it set up so that our meters will cancel, now we're looking for our numbers. We got to use our conversion factor to get those. So hectometer and meter, I need a conversion factor that has both hecto and meter in it. So which one has both hecto and meter? Right here, hecto and meter. In front of meter, we have a 100. So that's what we need to put in front of meter in our problem. Wherever it says 100 meters, that's what we need to have in our problem, 100 meters. Okay, now in front of hecto, we have a 1. So we put a 1 in front of hecto. So now we multiply across the top, multiply across the bottom. 1,211 times 1 equals 1,211. And again, that is hecto. On the bottom, we have 1 times 100, which is 100. Now we divide. 1,211 divided by 100. 12.11. So then our answer is 12.11, and then don't forget that unit, hectometer. That's the unit that we solved for. So again, guys, just follow the procedure that I showed you there. Take what you're given and put it over 1. Set up your next ratio so that the unit that you were given is going to cancel out by putting that unit on the bottom. The unit that you're solving for goes on the top. And then go find your conversion factor that has both units in it. Whatever number is in front of that unit in the conversion factor, that's the number that has to be in front of that unit in your problem. Again, whatever number is in front of that unit in the conversion factor, that is the number that goes in front of that unit in the problem. So make sure. It doesn't matter whether it's on top or bottom. What matters is whatever the number is that's beside the conversion factor in your problem, in your conversion factor, that is the number that you put beside that unit in your problem. So if it says 100 meters, 1 hectometer in your conversion factor, it better say 100 meters, 1 hectometer in your problem. Okay? So you can see sometimes the 10 or the 1,000 or the 100 goes on top. Sometimes the 10 or the 100 or the 1,000 goes on bottom. How do you know? You look at your unit. Whatever it has in front of that unit in your conversion factor, that is the unit that is the number that goes in front of that unit in your problem. Okay, so in our conversion factor, it was 100 meters, 1 hectometer. In our problem, it has to be 100 meters, 1 hectometer. Okay, so all of these problems are what I call one-step problems. Okay, because there is one conversion factor that has both units that I'm looking for, the unit that I'm given and the unit that I'm looking for. Both of those units are in the conversion factor. But what about when you have a unit that's not in the conversion factor? What if you have a problem where both units are not in the same conversion factor? Okay, so let's look at an example of that. So we've got 872 kilometers is equal to how many hectometers? So let's go ahead and write down our given and put it over 1. You always start the same way. 872 hectometer, or I'm sorry, that's kilometers or kilometers. $872 kilometers over 1. Again, I took what I was given and put it over 1. Now I want to cancel out kilometers, so where does it go? On the bottom. What do I want to change to? Hectometers, it goes on the top. Okay, so now I'm ready for numbers. I need a conversion factor that has both hectometers and kilometers in it. So let's look. Okay, here's a conversion factor with kilometers, but it doesn't have hectometers in it. It has meters. Here's a conversion factor that has hectometers, but it doesn't have kilometers. It has meters. So notice I have one conversion factor that has kilometers. I have another that has hectometers. Okay, so what do? I'm going to have to use both of those conversion factors. Notice what they have in common. They both have meter in common. So could I change from kilometer to meter using this conversion factor, and then change from meter to hectometer using this conversion factor. So guys, what we're going to have to do is we're going to have to take the unit that we're given and convert it to the unit that they both have in common, which is meter. So what I'm going to do is I'm going to convert it from kilometer to meter and then from meter to hectometer. So again, I don't have a conversion factor that has both of these in it. So, but I do have a conversion factor that has kilometers to meters, okay? And then I do have a conversion factor that has meters to hectometers. So if I convert this to meters, then I can convert those meters to hectometers. So I'm going to use two conversion factors. And again, guys, I know you're sitting here thinking, well, I can just do that in my head, oh, I can see that it's 1,000, it's 100, and some of you may be able to do that in your head, and that's awesome if you can, but that's not how I want you to do it. And the reason is because later on, when we start doing some of these harder chemistry problems that are multiple steps and they don't just involve powers of 10, 10, 100, 1,000, you're not going to be able to do it in your head, I promise. So it's very important that you can do it the way I'm showing you how to do it now. So, as I said, we're going to convert kilometer to meter first. So, let's go ahead and take this off. And again, that didn't work because I didn't have a conversion factor that had both kilometer and meter in it. So what I'm going to do is I'm going to change from kilometer to meter first. So from kilometer to meter first. Okay? And then in my next one, I'm going to change from meter to hectometer. So how do I get rid of meter? Where does it go here so I can cancel it out? It's going to go on the bottom. So meter, and now I'm going to be able to change to that hectometer. Okay? So an extra step here. I can't go directly from kilo to hecto because I don't have a conversion factor that has both kilo and hecto. I have two different conversion factors that I'm going to have to use. They have meter in common. So I'm going to change from kilo to meter first, and then I'm going to change from meter to hectometer second. So to change from kilo to meter, put kilo at the bottom so it will cancel out, meter at the top because that's what I'm changing to. And then in my next step, I have meter at the top, but that's not what I want. I want hecto, so cancel out the meter by putting it at the bottom, and then put hecto at the top. Now that we have all of our units set up so that our kilometers will cancel out and our meters will cancel out, and we're going to have hectometer as our answer, now we can get numbers from our conversion factors. So again, I need to use the conversion factor that has kilo and meter in it first. So kilo, it's 1 kilometer, 1,000 meters. So in my problem, 1 kilometer, 1,000 meters. Okay, whatever it is in the conversion factor, that's what it has to be in my problem. Okay, now we're going to use our second conversion factor that has meter and hectometer in it. So here's my second conversion factor. 1 hectometer, 100 meters. Again, 1 hectometer, 100 meters. So 1 hectometer, 100 meters. Okay, notice whatever it said in the conversion factor is what I have in my problem. 1 hectometer, 100 meters. 1,000 meters, 1 kilometer. So that's how you do this. Now we're going to multiply everything on the top. So we have 8.72 times 1,000 times 1. So 8.72 times 1,000 times 1. And that gives us 8,720. And again, what unit do I have? I have hectometer. That's the only one that's not canceled out. On the bottom, we have 1 times 100. So that's what we get on the bottom, 100. Now we're going to divide 8,720 divided by 100. And our answer is 87.2. And that's our final answer. Now, again, guys, I know some of you may be thinking, I can do that in my head. Why do I have to do all that? Because I said that's what you have to do. If you want to get credit, this is how you have to do it. The reason I'm making you do it like this is because later on we are going to be doing chemistry problems that are not going to be so easy that you're not going to be able to do in your head, and you won't be able to do it if you cannot set it up and do it the way I did it here. Okay, let's do another example. Again, take what we're given and put it over 1. 96 millimeters equals how many kilometers? We are given 96 millimeters. So take what we're given, put it over 1. Set up our next ratio. We want to cancel out millimeter, so it goes on the bottom so it will cancel out. We want to change to kilometer, so that's what goes on the top. Now I have to find a conversion factor that has both kilometer and millimeter in it. Where is kilometer? It's up here. Where is millimeter? This one does not have both in it. It has kilometer and meter. Millimeter is down here. Remember, this is milli, so I'm going to change this ml back to mm for my purposes right now. Okay, so millimeter and meter are down here. So meter and kilometer are up here. Millimeter and meter are down here. So again, what am I going to have to do? What unit do both of those have in common? Again, they both have meter in common. Meter here, meter here. So what I'm going to have to do is I'm going to have to change from millimeter to meter, and then from meter to kilometer, because both of the conversion factors that I need have meter in them. They're related by meter. I can change to meter first and then to kilometer. So again, I can't go directly from millimeter to kilometer, so I'm going to have to erase this kilometer. And I'm going to have to go to meter first. So I'm going to go from millimeter to meter first, and then I can go from meter to kilometer. So where do I put meter in this third fraction so it'll cancel out? I hope you said at the bottom. They have to be at the bottom. And then now I can change to kilometer, which is what I want. Okay, so now my meter will cancel out. I've canceled out, gotten rid of my millimeter. I've canceled out, gotten rid of my meter, and what's left is kilometer. Once we have it set up so that our units will cancel, now we're ready to get our numbers from our conversion factor. So again, my first conversion factor, I need to look at the one that has meter and millimeter. Okay, so that's going to be this one. 1 meter, 1,000 millimeters. Again, 1 meter, 1,000 millimeters. So in my problem, 1 meter, 1,000 millimeters. Okay, now I need to look at the conversion factor that has kilometer and meter. So that's going to be this one. 1 kilometer, 1,000 meters. Again, 1 kilometer, 1,000 meters. So 1 kilometer, 1,000 meters. Okay, whatever it says in the conversion factor, that's what it has to say in your problem. 1 kilometer, 1,000 meters. Now we're ready to multiply. 96 times 1 is 96. And again, kilometer is the only unit that we haven't canceled out. On the bottom, we have 1 times 1,000 times 1,000. If you don't know what that is, punch it in the calculator. 1 times 1,000 times 1,000. And that is, guys, 1 million. So on the bottom, we have 1 million. Now we have to divide. 96 divided by 1 million. So 96 divided by 1. There's 1,000. There's 1 million. And notice we get 0.000096. So we have a decimal, and then 1, 2, 3, 4 zeros, and then 96. So our decimal, 4 zeros, and 96, and that is kilometers. Okay, so that's 96 millionths. Okay, 96 millionths, like 96 millionths, and that is our final answer. So 96 millimeters is not very many kilometers at all, because kilometers, notice here, it should make sense to you. Kilometers is really big. Milli is really small. So it's going to be a very small number when you're changing these all the way up to these bigger ones. Okay, let's look at one more, or a couple more examples. I've got a couple more examples here because I know this is a little bit more complicated, and I wanted to make sure that you knew how to do it. So again, we're going to take our problem. 8,574.3 centimeters equals how many kilometers? Okay, so again, we're given this, and this is what we're looking for. So 8,574.3 centimeters over 1. Always take what you're given and put it over 1. Centimeters will go on the bottom so we can cancel it out. What we want to convert to goes on the top. In this case, it's kilometer. So let's look and see. Do we have one that has centimeter and kilometer? Obviously not, okay? We have kilometer and meter. We have centimeter and meter. So we can't go directly from kilo to centi, but we can go from kilo to meter to centi. So because both of those conversion factors have meter in common. So we're going to have to go to meter first, and then from there we're going to go to kilometer. So again, as I said, we're going to have to change from centi to meter first. So I was given centi, I put it on the bottom so it would cancel out, and I'm going to change centi to meter, so meter goes on the top. Next, I want to go from meter to centimeter. So I want to get rid of meter. Where does it go to cancel out? On the bottom. I want to change to kilometer. That's what I'm solving for, so that goes on the top. Now my meters cancel out, and I'm left with kilometer. So now I'm ready to look at my conversion factor. I need to look at the one that has meter and centimeter in it first. So here we have meter and centimeter. 100 centimeters, 1 meter. Again, 100 centimeters, 1 meter. So in my problem, 100 centimeters, 1 meter. All right, now we're going to use the other conversion factor that has meter and kilometer in it. That's going to be this one. 1,000 meters, 1 kilometer. Again, 1,000 meters, 1 kilometer. So in my problem, 1,000 meters, 1 kilometer. Now I've got everything completed. I've canceled out all my units. I have kilometer as my answer, which is what I need. So now I'm ready to multiply across the top. 8,574.3 times 1 times 1 gives me 8,574.3. And then again, kilometer is there. It's the only one that's not canceled. On the bottom, 1 times 100 times 1,000. I hope you can see that that's 100,000. And if you need to punch that in the calculator, you can. Now we're going to divide. 8,574.3 divided by 100,000. So 8,574.3 divided by 100,000. And my answer is 0.08573. 0.08573. 0.08573, and don't forget your unit, that's kilometers. Again, that should make sense to you. We're taking a very small unit and converting it to a much larger unit, so that's going to be a very small number. Again, centimeters is a very small unit. It's down here below the 1. Kilometers is a really big unit. So when you're converting from smaller to bigger, you should get a small answer. Okay, you guys, I'm going to change this to something different just because I don't want us to keep using meter every time. So I'm going to change this from, I'm going to say that we're going to change a decaliter to a deciliter. Okay, that's what I want to do. So again, we're going to change 1,247.5 decaliters to, and we want to know how many deciliters is that. So we're going to take what we're given and put it over 1. 1,247.5 decaliters over 1. And this is not equals yet. We're not ready to equal it yet. We're multiplying it. Come on. Okay. Now, we're going to set up our second ratio. Again, I want to cancel out deciliter, so where does it go? On the bottom. I want to change to what it's asking me for, which is deciliter, on the top. Now, do I have a conversion factor that has deca and deci both in it? No, I don't. Deca is here. So this is deciliter. And this would be just liter. Okay. Then my deciliter is here. This would be liter. And this would be deciliter. Okay. So notice again, I do not have a conversion factor that has both deca and deci in it. I'm going to have to use 2. So what do those two have in common? They both have liter in common. They both have liter in common. So what this means is I'm going to have to switch from decaliter to liter, and then from liter to deciliter. So I'm going to have to change this. I can't switch directly to decaliter. I'm going to have to change from decaliter to liter first. Okay, so that way my decaliter will cancel out. And then I'm going to change from liter to deciliter. So where does liter go so I can cancel it out? On the bottom. Deciliter, which is what we're solving for, goes on the top. Again, liter will cancel out. Now we're ready to look at our conversion factors. I need to look at the one that has liter and decaliter in it. So, which one has liter and decaliter? Well, it's the DA, deca. 10 liters, 1 decaliter. Again, 10 liters, 1 decaliter. So 10 liters, 1 decaliter. 10 liters, 1 decaliter. Now I'm looking at the conversion factor that has deciliter and liter in it. Okay, that's going to be deci. So 10 deciliters, 1 liter. Again, 10 deciliters, 1 liter. So 10 deciliters, 1 liter. Now our units are canceled out. Our answer is going to be in deciliters, which is what I wanted. So now we are ready to multiply and divide. So 1,247.5 times 10 times 10. If you don't know what that is, then you want to punch it in the calculator. 1,247.5 times 10 times 10 is 124,750. 124750. 124,750. And then on the bottom, and again, that's deciliters. It's the only unit that isn't canceled. And then on the bottom, 1 times 1 times 1 is 1. So when you divide, you get 124,750 deciliters. Again, that should make sense. We are converting a big unit to a small unit. So again, we're converting a bigger unit to a smaller unit. So that answer should be pretty big. When you're going from small to big, your answer is going to be small. When you're going from big to small, your answer is going to be big. Okay, I know that's a lot to take in. Please email me if you have any questions. If we need to do a Google Meet over this, please email me and we can set that up as well. And we'll be talking to you soon. Bye-bye.